Hello everyone, welcome to yourfaculty.com. Today we are going to deal with problems on averages. This is our website www.yourfaculty.com. You can take test preparations, questions over there. You can also visit us on our Facebook page, Your Faculty. Moving on to next question. The mean of 50 observations was 36. It was found later that an observation 48 was wrongly recorded as 23. The corrected new mean is very simple question. If you just apply the basic concepts of average. So what is the sum that you get with the values that we have? 36 into 50, right? Because there are 50 observations, so you write 50 here, and average is 36. So 36 into 50 is your sum, right? And then what is that they are saying? It was found that an observation 48 was wrongly taken as 23. So what does this mean? There's a deviation of this much value in the total sum. And what is that value? 48 minus 23. Why is that I'm saying? Because there are so many values out here and one particular number is 23 and the observations, there are totally 50 observations like that, right? And this particular value, instead of 48, they had mentioned 23 here. So if I'm replacing 48 by 23, anyway 23 is accounted for this sum, right? Now what happens here? I just need to find out the difference that needs to be added to this overall sum so that we get the actual corrected mean, right? So what do? We can just write as corrected sum is equal to 36 into 50, right? Plus 48 minus 23. This is the deviation that we see in the value overall sum, and that needs to be added to the initial sum that we got to get us what? Corrected mean. So the corrected sum will be 1825. And what is the new mean? Or the corrected mean? 1825 by 50, which is 36.5. Fair enough. We can also apply the earlier concept that I mentioned. What is the difference between 48 and 23? Equal to 25, right? So if 25 is the value that is missing out and there are 50 observations, what is 25 by 50? Is equal to 0.5. So the overall value has to increase by 0.5 and that is why it is 36.5. So you don't have to do complex calculation if you understand how mean or average works. So as I said, the deviation is 25 and number of observations is 50. So 25 by 50 is equal to, it's 50 here, is equal to 0.5. And we know the mean is 36 and the differences, and this particular difference is adding up the mean by 0.5. I'm moving on to my next question. The average age of 15 students of a class is 15 years. Out of these, the average age of 5 students is 14 years and that of 9 students is 16 years. The age of 15th student is what? Okay. So here I will apply both the techniques. You can take up whatever you want, whichever you are comfortable with. What is the usual technique? I'll first find out the total age of the class, right? Total age of the class is what? There are 15 students and the average age is 15, right? So this is 225. And what are they saying? They are saying out of that 5 students, so total age of 5 students is 5 students is equal to what? Total age of 5 students is 14 into 5. Am I right? 5 students is 14 years. So that's equal to 70. So you have 225 on one end, then 70. Then they are saying that of other 9 students. So total age of 9 students is equal to 9 into 16. 160 minus 16, 144, right? You can watch or separate video on shortcuts for multiplication. Anyways, this is the value. So we know that these are the values. So now the question is, what is the age of 15 student? So age of, I'll just write it over here. Age of 15 student is what? 225 minus 70 plus 144, right? Which is equal to 225 minus 214, which is equal to 11 years. Now, let's apply the shortcut. I will just write the first 5 students, the average is what? 14. So I'm going to write like this, 14, 14, 14, so on. So 5 students we have written 14. Next 9 students, what can we write? We write as like this, 5. So we have totally 9 students over here and 5 students over here. What is the easiest technique that you can quickly visualize? We know that the average age is 15 for the entire class. So in order to maintain an average age of 15 for this block across, we need to add one age, right? And where can we borrow that? We can borrow it from this block. Am I right? Which means we have 5 plus 5 ages getting cancelled out as 15. What are we left with? We are left with 4 more students who are contributing additional 4 ages. How are they contributing? It is 16 where you get 1. Similarly for all the other, totally 4, right? So you get 1, 1, 1 and 1 over here. So what does this mean? This means that there are 4 additional ages that are coming in, and hence what happens? The 15th student, if you keep the average as 15, has to come down by 4, which is basically this, and hence it is 11 years. I know it looks complex here, but once you start practicing in this model, you don't have to do any complex multiplication. It is very simple. What I did was I assumed that everyone in the class will have an age of 15. 15 students are going to have an age of 15. Now I understand there is a deviation of 1 for the first 5 students, and then that got adjusted with the next 5 students, which is 16 through 16. So with that calculation, I know that for 10 students my average age is 15, and I am left over with 4 students whom I know have an age of 16, 16 and 16, 16, and then I am left with 1 student for which I need to find out. For that 1 student, what did I do? I assume that I am going to borrow 1 from all these 16s, and I need to subtract 4. Because it is 1, we have 4 here, the sum of all those values is 4, and I already assumed that the 15 student age is going to be 15. So 15 minus 4 is equal to 11. Now I'm going to the next question.